4.2 is solving binomial equations. Binomial has this prefix bi, which means it has two of something. So in our math terms, it means it has two parts or two terms to it, and terms are always separated by a plus or a minus sign. The first ones are really easy. You're just solving a linear binomial. Linear means that it's always x or whatever variable to the first power. There's no squared, there's no cube, nothing like that. So if I have x minus 5 equals 0, to solve for x, I would do the opposite of subtraction and add 5 to both sides. Negative 5 and positive 5 cancel. 0 plus 5 is 5. And it should be able to plug in and make sense that 5 minus 5 does make 0. And then number 2, if I'm trying to solve this, this is a two-stepper. I've got x times 9 plus 1. You want to work backwards, get rid of your addition. So I'd subtract 1 on each side. 1 minus 1 cancels. Bring down the 9x. 0 minus 1 is negative 1. To get rid of the times 9, I would divide away the 9, because 9 divided by 9 makes a 1x or x. And then that does not simplify, so x equals negative 1/9. So if I were to plug that back in, 9 times negative 1/9, the 9s can divide away. That'd be negative 1 plus 1 does make 0, so it works. Second half of this is solving quadratic binomials. Quadratic means that it has something squared. So x squared could be any letter, but in all of these we'll see x being squared. On these you're going to get two solutions, and I'll show you why. This one says, what number squared minus 49 is 0? If I wanted to solve this for x, you would still isolate this x squared part, so I would add 49 to cancel that and move it over here. 0 plus 49 makes 49. Bring down the x squared. When you're solving the equation, you want to get x alone. The opposite of squaring is square rooting. So I'm going to square root both sides. So square and square root cancel. That brings the x out. Square root of 49 is 7. But I want to think about this. If I plugged 7 in, so that would be 7 squared minus 49 is 0. 7 squared is 49. 49 minus 49 makes 0. But is there another answer that would also work? I hope you're thinking if x were negative 7. Negative 7, that quantity squared, negative 7 times negative 7 is 49. And so 49 minus 49 still makes 0. So what you get are two answers, and we write this little plus minus sign in front of our number. So you have to remember that when you square root in an equation, that means you get the positive and the negative version of that answer, because when you plug it back in and square it, they both become positive. Okay, number 4, we want to get x squared alone. So think x squared is being multiplied, then subtracted. Work backwards to solve. We would add 25 to both sides. That cancels. Bring down your 36x squared. That equals 25. Divide away the 36. And this might freak you out seeing this. That's okay. Leave it alone because it doesn't simplify, and you're going to get a decimal when you divide. So I'll have x squared equals 25 over 36. Square root. To make the square cancel, square root this whole thing. X will equal, remember you'll get a positive and a negative answer. Square root of 25 is 5. Square root of 36 is 6. So you're just square rooting the numerator and the denominator. All right, number 5. Easy enough to solve. I would add 10. And then square root. Square root cancel. Remember plus or minus. Square root of 10 cannot be broken up, so it would just simply stay square root of 10. And think about plugging that in. Putting a square root of 10 quantity squared. That would make 10. 10 minus 10 does make 0. Think about making it negative. Square rooting a negative, or not square rooting, sorry, squaring a negative makes that 10 as well. And so they both work. And then number 6, easy enough. You'd subtract 121. That would be a negative 121, right? I'm at 0, I go back 121 spaces. Square rooting, we cannot technically square root a negative because there's no number times itself that makes a negative, but Remember we learned that that's imaginary. So we would get plus or minus, square root of 121 is 11, pull out I to say that's an imaginary number. And that's all there is to it.